Okay, it was a great introduction, thank you. And I'm also excited to start talking about such a great topic as cloud technologies, cloud platform, especially after a keynote from David, who devoted mostly half, even more of his talk about technical achievements about to the cloud, to the Google Cloud, to the Google Cloud platform. So I decided to name my talk. It's Go in the Cloud. It's a quite interesting play with the words. So I propose now to you to go into the cloud. Um, so Go actually, who knows? Raise the hand. Who knows what Go is? Golang is another synonym for that. Great. I will talk a little bit, just mention what Go is. So this is actually a good mascot of Go language that should picture the gopher. It's an interesting animal. So Go is actually it's a language that and set of tools that used to compile code. So at the result, we get a compiled version, binary version, ready to execute to be executed on different platforms. Currently, Go can compile to Linux, to Windows platforms, to Microsoft Windows, Mac, and Linux, and also now there is a possibility to run compiled Go applications into even Android. So, and one of the main features are that it is a concurrent language. I mean that there is concurrency is in the core feature of this platform. It's very easy, I will show you later, to write applications that that utilize all resources, all cores in a host where this application run. Also, it is a garbage collected, so you don't need to take care on a memory allocation, memory free. It's like in application or languages like Java or C# or any other, but interesting that it is actually a strong type, a statically typed language, so it's more close to C, C++. Interesting that there is a lot of companies that are rewriting their Python applications into Go, and it is very very easy because it's a really high level language, but it's statically typed and it's compiled language. So, and another and the last feature, it's I consider this actually feature that actually this language were developed internally in a Google, inside of Google, and moreover there is a good article called Go in a Google that describe how Go appears. Initially, it was a private project inside of Google just to make sure that all developers are spending their time for writing some good stuff and for value for the company, not just writing a lot of code like includes, like type devs and macros that actually brings no value to the company. Just imagine in a Google there is just for example, about 1,000 developers, and they have quite good salary. Just imagine if we can write something that we can save, for example, 10 minutes per month per one developer. How many company will save? So Google decided initially the first version that it was not publicly disclosed of Go. It was just a transcriber from some more high level than C, C++ code into C, C++. So it's kind of TypeScript for JavaScript or CoffeeScript for JavaScript. The same was for C. So Google want to have a really performant application, but don't want to spend developers' time for writing things that are bring no value to the company. So as you can see, there is this graph shows popularity of the Go. It appears in 2008 or open source in 2009. The time was mostly no committers, no public repositories, no commits here. And as you can see now, starting from 2013 and for in this year, it is extremely big race of public repositories of committers of a code written in a Golang. Why? So this question is, why if this language appears 4 years, 5 years ago, why it was kindly ignored by many communities, by developers communities, by developers themselves and the companies? Actually, the answer is cloud. Interesting thing that I was using Google Golang for about 1 year or 2 years before, and I was starting doing this presentation, and I was sure that I know mostly everything about Go. But when I wrote several points and started digging on them, I understood that I was wrong in some points. For example, I consider the Go as it's a binary language and it compiles to binary code. There is mostly no runtime or virtual machine. It should be extremely performant. But actually, there are some cases where Java applications run faster. So, what's the point? Actually, the answer is that when you compile Go application into this binary image, or you can run it on any instance of operation system that's for each it was written for. So there is no need to install any additional requirements, any virtual machine, any DLLs or shared libraries. Go doesn't support shared libraries. It's just simple file. So you can spawn, for example, in a cloud, you can spawn any amount of clean virtual machines, deploy one single file there, run it, and you'll have your application running. So actually, popularity of Go is more about when just cloud becomes popular, and many companies were investigating in which language, in which platform they should use. Go becomes #1 this solution. Also, I think very important here to mention, by the way, this image was shown in a keynote of David Ostrovsky previously. This is a photo of a Google data center inside of, and here I would like to talk a little bit about Google Apps Engine, App Engine. Yep, there is a big difference between Google Apps and Google App. Only one letter, actually, but Google App, it's about cloud platform. Google Apps, it's a Google Drive special language where then you can write scripts for Google Drive. So please be careful. So Google App Engine is a platform as service solution that you can write the code in your favorite language. It could be Java or Python or PHP or Go. That you just write code, put into this App Engine, and Google take care for everything else. It take cares about installing, spawning virtual machines for you. It take cares about deploying your application, compiling and deploying your application into this virtual machine, powering up and shutting down on the request. So very nice platform that you don't care about how it done internally, which version of operation system that your code will be running on, and no any problems with updates of this. So you just write a code, put it there, and it's working. Moreover, it has a free quote, so everyone can just write an application and test or play with it until you will have a really big load, and only then you need to pay something. But if you're writing in a Go, you can it's hard to imagine which load of your application should be to run out of the free quote. If you write in a Java, each time the application is started, Java virtual machine should be powered up, all libraries should be resolved and run. With the Go, it's very quick and very nice. So it's another topic that I would like to actually there is a very short amount of time. I'm now really condensing many topics, and if you are got interesting, I'm glad to speak with anyone who can come to me, and I can give more information about that. So it's just only salt. So Another important thing, it's about microservices. Microservices, it's I think is a big the thing that differs scaled application and really cloud application. When you just write application that could be scaled, it's actually not a cloud application. You could use it in any other platform or Amazon or anything. But if you divide your application into small pieces and let each piece focus and isolate its own functionality, it become microservices. There is a good article written by Martin Fowler and James Lewis about microservices that describe the difference. You see, in the left part is a scaled application, where is all functionality scaled within different virtual machines. And on the right side, you can see that virtual machine can contain different amounts. For example, this virtual machine, the last one, doesn't contain any some microservices available into others. So it's much more graduate way. I advise all of you to check this article about what is microservices. So let's show some code, because only theoretical stuff for me I'm become a little bit boring about that, because I'm also a developer. So the most important file in any application that runs in a Google App Engine, it's definition of a file, or it's a YAML file that define all properties of this application. And here's a typical application for a Google App Engine that allows you to run a Go apps. And but this application define only this file define only one application. So within with this configuration file, you will have only one executable run in the virtual machines, different virtual machines. So it's a good enough if you have some small file or some small project just to test. But within Google Apps Engine, there is a possibility to run that one application can define different models. And these modules, actually, there is a microservice. Each model is a microservice. So one application can define different models. Each model can have separate version. So for example, you can after you deploy the application with the different microservices or models, you found some bug, and you can upgrade only one these microservices to another version, and all system will still functional. So this structure shows. Previously we had only one YAML file. If we decide to use microservices, each model has own configuration file. And here is an example of this configuration file. So what the difference? The first is that on the second line, you see that the name of the model. For example, this configuration file define a default model, or default microservice. It could be the front end part of your application. Another thing that you see, you can define different handlers. It's for example, for a last two handlers define that for a static files, there is no any processing should be made. Interesting that if you define in such way, all functionality of serving static files, including caching, including get-tag support, including ranges requests, so quite complex questions already would be solved by Google code. I mean that you don't need to write any static middlewares like in Node.js, or write any code to serve static files. Google will take care about that. But for API calls, you see the first handler, I would like my Go script to be referenced or to be used. So each model define a file like this. So it contains some static files and scripts that serve API request. And here's main entry point for a service. as I saw that not a lot of people understand the Go syntaxes, but actually if you can just read it and consider it like something new, and you can see that it's quite easy to understand. For example, this code defines one package. Package is a kind of model or unit. After that, you can you just mostly all languages, Node.js or C#. You always start your code or file with dependencies on which this code depended on, and you can see that or require that file. This model require HTTP and JSON's model. Google or Go ships with a lot of models, so mostly 90% of all standard functionality you can need already covered by standard packages. But also Go has a very nice tool for getting packages or from GitHub or other repositories. It's mostly same as for Node.js you use npm. For C# you use NuGet. For other languages there is a lot of package managers, and Go has a package manager bundled in itself. So for example, if you need some package, you can write in a command line go get something. By the way, what I like with the Go, that many things that you need, you just can write go run something. Go, so quite handy to read and to write. After that, I defined some function that it's a bootstrap of this model. And what I can say that for all requests like API customers, I should this handler handle customers should be used. So syntax it's very close to C. But the big difference is you can see in a definition of this function handle request, the type of the variable is specified in the end, not in the start, in the end. Reason behind that, as stated by creators of Go, they said that it's for a human being, it's much easier to read that W is a type of what's that? W is type of HTTP response writer. They used another argument for that, that any dumb developer can write the code that would be understandable by machines, by computers, but only wise developers can write the code that will be understandable by humans. So there's some changes in syntax comparable to standard languages like C#, like Java, like JavaScript and other. But after spending, I don't know, several hours reading Go code, for me it was very easy to read it without any digging big documents or libraries for that. So also, for example, here I define at the end variable customers, and I don't need to specify the type of this variable. As you know, in C++ there is something called auto that you can do the same. In a Go, you can just skip this. You can just say that I define variable customers that should be the result of what goes after that. And here goes one of the most exciting things in a Golang. Unfortunately, it's not focus of this beamer is not good enough, but I can say that there is written that customers is defined as a result of make a channel that has a type of array of customers. What is channels? As Golang has a concurrency in its core, you can run, of course, different tasks in a parallel. But how to synchronize between them? All other languages like Java and C++ has a lot of libraries or APIs, how you can synchronize workers, how you synchronize execution threads. But in a Go, there is only there is a main thing how to synchronize is the channels. Channels is something that you can imagine it like a pipe between someone. So pipe with a one-way pipe. You can push something from other side, from one side, and someone can pull it from another side. So here, for example, I define this channel. Channels, by the way, could be two-way, one-way, and so on. Here I define a two-way channel. Actually, I can use a one-way in this case. After that, I wrote go get customers. You see, if I remove this go before that, this file, this code still will be compiling, not very functional, but still you can run it. So what the difference? What this small keyword go before the function invocation means? That means I want this function to be run in a parallel. They don't call it threads. They don't call it workers or tasks like in a C#. They call it Go routines. So this routine, get customers, would be run in a parallel, and Go runtime will take care about what is more efficient right now. Should it be created a new thread and this Go routine would be run in this thread, or some thread already become available so it can reuse, or just call it this function in asynchronous way. So for example, if Go could be run even in a single thread environment, and in this case it would be asynchronous call to this get customers. After this execution would be paused and get customers would be called. So I run what I should care to write the in case if I want some forking, I just write go something, go do something. In this case I said go get customers and pass this channel to this function. So I pass this pipe, and after that here's another I call a new encoder to encode the result. So this is very important thing in a Go line. Here customers is actually the channel, and here I wait something until something come from this channel and go to this encode function. So actually you can see there is a quite easy syntax. Just you need to if you already know Java code or C# code, JavaScript code, you need to spend only 40 or 1 hour, 40 minutes or 1 hour to get acquainted with that. There is, by the way, a good solution for that. Here's, I don't have a lot of time to comment it, but here is implementation of this get customers function that will be run in a parallel. Actually, all the slides are available online. Later, I will show you the link for that, so you can check this code. But in general, there is the first line. It's a definition of a static array, just for example, and the second line, as you see, I got as a parameter variable result of type channel, and the second line of the function just push this array to that channel. There's important to note here that it is very nice decoupling of the code. I don't care who will receive this my message, my array of customers, but I just push it there, and that's all. I don't know in which thread will receive my message. Okay, so but that's yep. And of course, in the microservice, if you have a lot of services run in a parallel, and you have many virtual machines serving your code, sometimes you need to call one microservice from another microservice. And here's a simple code that will do this request to some other microservice running within same application. And as you can see, it's, by the way, absolutely synchronous code, so it's not run in a parallel still. When you're writing code in a Go, you shouldn't care about how many Go routines are run in a parallel. You can run this code with a Go, so as a Go routine. and Go will take care about all performance things. And actually, Go was designed in such way so that in a even some not very performant PC, you can run 20,000 of Go routines. It's really great, and I really tested it. So it created about 20 parallel threads, and we're managing about the execution of these Go routines. Okay, and here is example of when I deployed this application on Google App Engine. I saw that one instance we're using only 5 megabytes of RAM. That's all. So for average application, memory usage could be about 10 or 20 megabytes of RAM. And as you know, in one of a feature of any cloud platform that you pay for resources. If you don't need 1 gigabyte RAM in your virtual machines, you can just use much smaller and cheaper instances. So the good thing with the Go is that you can write in a quite high-level language, and it compiles in a binary, and memory footprint is very low. Another example, this is from a management system of Google App Engine. It's a log request. And as you can see, this request took 88 milliseconds. You can say, wow, it's quite big for some request. But actually, this is it's even in the logs colored in a yellow background, because this request caused a new process to be started. So actually, 80 milliseconds is enough to spawn a new virtual machine and run this application in this virtual machine. This is just because starting a new application with a Go is very quick. You don't need to start up any runtime, any virtual machine. You just start it. So 80 milliseconds was enough to start a new instance of some microservices or some service. So that's I want to show again. As you can see, this, what I described previously, resulted such a big race of committers. Okay, now who actually use Golang? And I now will try to sell this technology for you. The first, of course, users of Golang is Google itself. For a long time, it was a confidential product, and nobody knows about that, only developers within Google. After that, they open sourced it, and currently there is no public list of all applications that are written in a Go language and run within Google. But public things that you can see that YouTube team using quite a lot Golang. Also MySQL service management was written completely in Golang. Also download Google.com. It's a very high load service, as you probably know. So mostly all images, all things you downloaded from Google.com is served actually by Go. What else? Maybe you heard something about Core OS. It's a new operation system that were released not so long ago by Google guys. Actually, it's a very, very small minimalistic operation system based on Linux. And mostly all managements, it's used in a cloud. If you need to very quickly spawn new instances of operation system, you should limit it with, so it should be very light. And many tools for this Core OS was also written within Go. But also there is a small list of all companies that are publicly stated that they are using Golang. You can notice some like Canonical, like .cloud, like Dropbox, like GitHub, like governments authorities in the UK are even publicly. So there's not complete list, but it gives you some idea that actually Golang is not so it's really production ready. It is already used for a long time by Google and by many other things. And if you want just to try it, you can just go to the website playgolang.org and write some code, some examples, and they will be executed right in the browser. So you don't need to download anything. You just press run and it runs. So another great site is a tour golang.org. It's actually this tour. After completing this tour, you will have a sufficient knowledge to write and quite productional code for based on Golang. Actually, after my talk, I would be really glad if at least 5 of you will go to this tour golang.com and pass at least 20 steps of this tour. And it's quite funny. This tour contains some exercise that you should really code on the left, press run, and see the result. Go next. So now we have not much time. Actually, my time is finished, but maybe someone has some questions for me.
If someone has questions, just raise your hand and I will come to you and give the microphone. So.
Okay, I think if anyone will have a question, I'm available all the day. So I think all conferences, especially the DevFest, has really great chance to speak with the people, to get acquainted. So don't hesitate to come to any speaker, to any person, and to talk, to ask, to share some things about that. So thank you for this. I would like to also say that I missed my small introduction, that I'm organizer of a GDG Kyiv Center. I'm specialized on a web platform in Chrome OS and web apps. And for a cloud, as you can see. So if anyone have any questions, not about cloud platform and apps engine, but also for about web, you can come to me. By the way, this presentation is completely HTML5 CSS3 based, all animation things. So as you can see, that I would like you to take some attention not only in the cloud solutions that Google, but also for web technologies, web things that Google proposed to all of you. So, thank you.